Welcome back to this page, and today we'll be talking about the properties of enzymes, and we're looking at three specific properties. We'll be looking at the active side, we'll be looking at zymogens, and we'll be looking at enzyme specificity. But before we proceed, if you haven't watched some of our videos, we have amazing videos on health knowledge and especially on sciences. If you haven't watched our videos, if you haven't subscribed to this channel, trust me, you are missing a whole lot, and I encourage you to go back, watch our videos and subscribe to this channel. Now let's go back into the properties of enzymes, or properties of enzyme action. Now the first thing we're talking about is the active side. Now what you have to take note of about the active side is that the active side, that is where all reactions for enzyme actions take place, because that is where the substrate binds to the enzyme. And understand that enzymes are so specific in nature. Now enzyme being so specific means that the substrate, or the substrate needs to be complementary to the active side of the enzyme before any binding will take place. Now the active, and one enzyme has multiple active sites, meaning more substrates can bind to the active site depending on the complement, or depending on how complement the substrate is to the active site of the enzyme. Now, and if the substrate is complementary to the active site of the enzyme, there will be a bonding which is going to lead to the formation of the enzyme substrate complex, and afterwards there will be the formation of enzyme product complex, meaning the products have been formed and it is going to dissociate from the active side of the enzyme, and the enzyme returns back into the reaction to pick up more substrate. So that is the active side of the enzyme. The next thing we're talking about are zymogens. Now we'll talk about zymogens. Zymogens are enzymes which are inactive but require specific environment to be active. Example, let's look at pepsinogen. Pepsinogen is one enzyme which is produced in the stomach and requires the pH of HCl to be about 2 for it to be converted to pepsin, which converts proteins to peptones. So that is that about zymogens. Now the next thing we'll look at is specificity. Now we'll talk about the specificity of enzymes. I know when I was talking about the active side of that enzyme, I made mention of the fact that the substrate is supposed to be, the substrate needs to be specific to the active side of the enzyme. But under specificity, there are two types of specificity. The first one is absolute specificity. As I explained earlier with the active side, absolute specificity just talks about the substrate being complementary to the active side of the enzyme before the bonding can take place. Unlike the next type of specificity, which is stereospecificity, which talks about the enzyme being specific to a particular stereoisomer of the substrate. For example, glucose oxidase catalyzes the reactions of alpha dextrose glucose, not the beta form. So that is what stereospecificity talks about. In summary, the enzyme being specific, or the enzyme catalyzes the reaction of a stereoisomer of that particular substrate. And absolute specificity just talks about the complementary state of the substrate to the active side of the enzyme. That said, we have come to the end of the lesson. So we're looking at the properties of enzyme action, and I hope you learned something. Don't forget to follow for more. Thank you.